One particularly powerful and beautiful idea in computer science is that of the higher order function, a function that takes other functions as data. So I'll give a little example here in Python. And even if you've never seen something quite like this, or even never seen Python, I think what's happening here should be clear. So in Python, we can define a function 10x that returns 10 times x. That's it. So I do 10x of 5, and it will return 50. Now I can actually define a function, say do twice, that takes two arguments. One that you expect to be a function, and the other you expect to be some kind of argument to that type of function. And so in that case, we could do something like return the function applied to the result of the function applied to x. And so I can, for example, say, Python, please print for me the result of doing twice the 10x function to 2. So that'll do 10x of 2, which is 10 times 10 times 2, which is 200. Okay? So what we're going to try and do is this same program, but in Java. And we'll see it's a little more challenging, a little bit kludgier than it is in Python, but this idea, it turns out, actually is very important. So in older school Java, Java 7 and earlier, you had to do it in a somewhat indirect way that we'll be exploring through the rest of this video. And the fundamental issue was that memory boxes, or aka variables, they cannot contain pointers to functions in the old versions of Java. So we can't write a function that has function type here. Remember that in Java we have to do type checking, and there just was no type for functions. You couldn't do it. And so instead, the workaround was to take advantage of interface inheritance, where we would define some abstract functiony thing that doesn't have a specific function in mind, and then we would implement that class, and we would override some otherwise undefined method. Okay, and we'll see what that means in a moment. Now, of course, in modern Java, you can actually do this, but for so long, Java programs are written this way that it's the default way of thinking in a lot of cases, like comparators and any other number of things that we'll be talking about in the coming weeks. Okay, so we're going to stick with this approach, and if you want to try out the new Java 8 or the newer Java 8 stuff, I'll have a separate supplementary video at some point you can check out, but this is the way we really need to learn things now. Okay, so let's just try it out, and it'll be a little strange until we're done, but we're going to start by making our int unary function class, or interface. And so the int unary function class, this basically, we're going to say first, represents a function that takes in an integer and returns an integer. Any function, right? It could be 10x, it could be squaring, whatever. Now we're not going to actually specify what function in particular. We're just going to say public int apply int x and call it a day. There's no default. Now actually I want to note here, this public keyword is underlined, and IntelliJ is yelling at us that public is redundant. So in keeping with common convention, I'm now going to omit that from our code. Okay, doesn't do anything, having it or not. So now we're going to actually implement a specific int unary function. In particular, let's write a function that returns 10 times its argument. So this 10x class implements int unary function. It has a public int apply method. That's what it needs in order to compile. Actually, it needs to have int x. And in this case, it returns 10 times its argument. Okay, returns 10 times the argument. So that's easy. Return 10 times x, and we have now written 10x. Okay, great. So what we built is this on the right, which is the equivalent of def 10x. Now we can see it's a lot kludgier. In fact, here we have it spread across two files, that one and this one, and that's the equivalent of def 10x. Okay? So again, Java's pretty verbose. So now we're going to say new class, and we're going to do a little demo. We'll call it Hoff demo for higher order function. And this demonstrates higher order functions in Java. So this is going to be these other two calls. So we'll start by writing the do twice method. So I'll do it as follows. Public static int do twice. Why static? Because I don't want to have to actually instantiate Hoff demo. And what we're going to do is we're going to take an int unary function, f. I'll do, yeah, f seems fine. And then we'll do int x. And in this case, we're going to return f. It's not f of x like it was in Python. It's going to be f.apply of f.apply of x. So basically, we've used inheritance as a funny workaround to get the same practical effect that we got in Java, or sorry, in Python more directly. Next, I'm going to show you how it can be used. And we'll see it's a little funny. So I'm going to start by saying, well, I guess I'll set aside an integer, 2. And then I want to print out, do twice, 10x x, let's say. Well, let's just do 2 directly. Why not? Okay. So when we try and do this, we get an issue which says expression expected here. So 10x actually is the name of a class, and it's expecting an object. So in fact, what we need to do is instantiate our 10x object, so we can do something like this. We'll say int unary function 10x equals new 10x. It's a little, well, it's better to be lowercase. So 10x equals new 10x. And now we pass an instantiated copy of the 10x class. Now it's a little weird, but that's typically how things are done. So if we run this now, we should get back, wrong one. The vengeful S list, it remembers. It's still very upset about it. Its members being deleted. But here we see 200. Okay, so that's Hoffs in Java. So on the left, I have all the code we just wrote. And I guess the main thing to keep in mind here is that while you can't directly do it in Java, Inheritance provides us with a way to actually accomplish the same thing. And we're going to be using this a lot in the coming week, actually a couple weeks. So the very last thing, we're going to call it a day here. I put together here an inheritance cheat sheet that you can use to remember how all of this works. I'm not going to read it off right now, but be aware that this is here for your reference. So that's it for this set of videos, and I will see you next time when we'll go a little deeper into higher order functions and beyond.